welcome everyone. Thanks for coming to my talk. Can you all hear me? I guess the room is not too big, so it should be fine. My name is Soraya Hausl. I work at ASOS.com on recommender systems, and my talk today is about actually leveraging recommender systems to personalize search. First, for those of you who don't know ASOS, we are an online shopping platform or an online shopping store. We sell clothes, fashion, so we are kind of fashion destination for our target group is mainly people in their 20s, so young customers. There are some stats on this slide about our customers. We have about 40 million customers, about 85,000 products, so that's quite a lot of products to go through. Some other stats about orders and visits to our platform. Today, as I said, I want to talk about search and personalizing search. So the standard situation that we have on ASOS and I guess on many other platforms is that we have a customer. The customer has some sort of intent. For example, we have, let's say, a female customer who's a student, who has a budget, and they're searching for shoes, so they get some result. We have another customer of who we might know that they always buy certain trainers or certain specific shoes. They would search for shoes and actually get the same result. And then you can imagine another customer where we also already have some history, and they might get the same results again. So this is obviously not ideal. Every customer would get the same thing, and because we already know something about that, we could improve search by personalizing things. So this is also our motivation behind it. I guess like many other companies, we have the standard case that search is unpersonalized, and this is something where we thought as data scientists that this is something that we can do something about. So we said, okay, we can look into personalizing search. Then obviously if you can say that to some other people in the business, a lot of questions come up around that, like how could you do that? What's the risks? What's the possibilities? There are some machine learning techniques like predictive modeling, using concepts like matrix factorisation, some other bits to actually make that happen. And what we wanted to do and what motivated the POC here was on the one hand to look into what are search improvement levers that we can use. How can we actually implement something relatively simple where we use our existing work, in this case from recommendations, and just transfer it to search, so kind of not having to reinvent the wheel, but just using existing capabilities, and also just build something relatively quick to showcase to other people in the business so that they can understand how could this look like, what could be potential risks, what could be potential use cases, and also just make data science more tangible for the business. In this case, we didn't want to kind of from the scratch build like a perfect solution, but just initial POC. So when we talk about personalization, we mostly think of it as re-ranking, not filtering necessarily. So the case is that we have always in search some sort of query term that the customer puts in. We want to retrieve all the documents that are relevant based on this query term, and then re-rank it based on what we know about the customer. So not necessarily filter it, because we still want to allow the customer to basically find anything that they want to find and not subject them too much to a filter bubble, but still hopefully surface the most relevant results first. As with many other problems in data science or machine learning in general, there's no one optimal way to do it. In personalization and search, there are kind of many trade-offs that we can think about. So on the one hand, if I have a very specific search, so let's say in our case we search for, I don't know, like a blue trainer from a certain brand that has a certain name, then most likely there will only like very few products being returned. In that case, there's no point in kind of thinking about complex personalization models, because if the customer can see everything, then we don't need to personalize. Also, there's always a question: to what degree do you want to personalize? Do you want to infer everything about the customer, just completely re-rank everything? Do you want to balance for some other use cases? So for example, maybe the customer is now looking for something else or is searching for a gift for someone else. So how can we balance all these things? Well, we started about on this. We're thinking about what do we know about the users already. So because we have quite a large customer base, we have a lot of information about them already. So basic things like demographics, easy things like gender. We have preferences. So if a customer has been active before, we know what sort of brands or product types they like. We can look into item similarities and factors, and a bit more about that later on. So we can prioritize certain items that are similar to what the customer has viewed before, or similar to what the customer has bought before. Or we can look into product and customer factors, which basically encode the taste profile of the customer. And this was kind of the focus of our POC. And then there are other aspects that we could look into, like customer segments, context. So for example, what's the certain time of the year? What's the weather? What's the seasonality? And also think about how can we optimize short-term versus long-term preferences. So for our work, we used a couple of various tools. So on the one hand, for the sort of data preparation and getting the user-specific data, we worked with Spark and Python. Then importing the data into Elasticsearch. Using for that, I used Jenkins just to automate the job on a daily basis, and some Java code to make that happen. And then for the actual search functionality and the personalization, I used Elasticsearch, JavaScript, and Microsoft Azure. Just kind of, this is the framework that we use for a lot of our work, and it's quite easy to set up Elasticsearch on a cluster there, on a VM there, and that worked quite well. And then we had quite a simple front end on top of that that just used JavaScript and HTML. In terms of the actual personalization, we can look at a couple of different factors, as I said. So one is basically just user preferences. For that, it's very easy to get that. It's basically just simple counts. So we just get things like what are the most common brands, for example, that they bought, or most common brand product type combinations. And we can come up with weights for that if we want to, or just use simple counts. Then looking at recommendation algorithms, what can we leverage from there? And I don't want to go too much into detail of recommendation algorithms, but just some main concepts behind it. So one major concept of recommendations is collaborative filtering, where we use the collective user interaction with products, and based on that, infer what are similar products or how are products related. So basically, in this example, the two dresses would have been usually interacted in the same way with by various customers, and hence our algorithm has established that they are somewhat similar, and we can use that in our search later on. Or we could work with a technique that's called content filtering, where we actually look at the actual product and the product attributes to understand what is a similar product. So in this case, the two shirts are of the same color, the same product range, maybe same price point, similar brands, and we can therefore establish that they're similar and use this in our search later on. So for example, if I have looked at one of these shirts previously quite a lot in my session, then then I search again for shirts, I could bring up the other shirt because I might be quite interested in that, or it might be quite useful for me. And then another main technique in recommendations is matrix factorization. So the concept there is that we have a lot of users, we have a lot of customers, but quite often the data about interaction is quite sparse, because I think on average our users, they shop around 6 products per year. They interact with some more products or view some more products, but for most products they don't have any sort of interaction with that. So if we want to infer how they think about other products, we need some additional information. And for that we use matrix factorization, which is a technique where we basically just establish a large matrix with all the user and items. Wherever there is a known interaction, we put in a weight. Everything else would stay empty. And then we use decomposition techniques to actually come up with a lower dimensional representation of these matrices. So we then we would then have an item factor matrix and a user factor matrix. And basically, if you would again multiply them, then you would have like an approximation of the original matrix. And the nice thing about that is that it's in the end comes up with quite a concise representation of a user and a product profile. So if you think about it, if you would only have like 3 dimensions, for example, price, color, and brand in this case, then you could map the user, or you could establish where the user lies in this space, and also map any sort of product to the same space, and come up with a sort of affinity or closeness between users and products. And these are the main concepts that we made use of in the personalization of search. The applying that in Pyspark is quite easy. It's just a couple of lines of code where we just actually calculate the factors. So these, for example, would just be the factors. And we can then also use that to come up with item similarities. So in our case, we looked at the output of matrix factorization and used ultimately all the item factors to establish how close are the different items compared to each other. So in this case, you could see that, not surprisingly, mostly items from the same product type are quite close to each other. So for example, a lot of dresses would be quite similar to other dresses, but you also see overlaps to other product types. So for example, dresses lapping over with tops or with skirts. And that's something that we can make use of, again, in our search personalization. And within Spark, it's, again, just a couple of lines of code that we can use, where we just use the results from the matrix factorization and basically just say, OK, if we set the user factors equal to the actual item factors, then instead of recommending products per user, we can basically just recommend products per other product and work with that. So this would give us all the sort of different personalization elements that we need. How did we actually implement it in our POC? So we looked at actually comparing the standard way of searching, where we just went to our standard search API and retrieved results based on a search term. And then in our personalized version, what we did was, again, we would go to the standard search API, get all the results, but then feed that into Elasticsearch. And use that as a tool to re-rank the results. For those of you who don't know, Elasticsearch is basically a RESTful API-based search engine, which is based on Apache Lucene, and that tool allows for kind of quite powerful search techniques. You can do any sort of standard full text-based search, but also include other tools to customize the search quite a lot in a way that is useful for your purpose. And it's relatively easy to set it up. There are a couple of different tutorials on the web, and we just used the Microsoft Azure tools to set up a VM, install Elasticsearch on top of that. Created a couple of nodes within the Elasticsearch, and you can scale that quite nicely based on how your data looks like and how big your data is. And for any sort of data set that you have, you basically create an index. And within this index, you can store any sort of documents. For example, if you have customer, then each customer would be a document, and we can store all of them on the server, and then just retrieve the information from Elasticsearch. And the retrieval is just based on some RESTful API methods. So we have some GET calls, POST calls, and so on. In our case, we basically just had like 3 relatively simple indices. So one with our customers and the customer data. So for example, things like gender preferences, or just the customer factor. All our product data with the product properties, and then signals. So basically, previous customer interaction with products. And then the way we went about personalizing the search results was in the first step, just to get the customer information. So we usually know who the customer is, so we just get all the data. We have information, for example, about the gender, about the brand preferences. So in this case, for example, it would be that the customer is most interested in Tom's shoes, or so it has color preferences for black dresses. And for example, just getting the customer factor and getting previous customer product interactions. So just, for example, the last maybe 3 products that the customer has interacted with. And we can then think about what are the sort of personalization levers that we actually want to set. So for example, do we just want to upgrade all the items from the same gender, or use more the recommendation techniques of similar items, or using actually the factors. And personalization in Elasticsearch, how does that work? So basically, there are 2 main techniques how you can implement that. One is basically just boosting, which just means that you look at the items that are retrieved. So for example, if I just look for, let's say, blue items, in this case, we get a couple of things back from the search, and we could then say, OK, I know the customer is a male, so we just want to upgrade or boost all the male items, and we just simply re-rank it based on that. or we use something a bit more complex, like for example the recommendation factors, where we just look at the items, look at all the factors. So basically, this very concise, low-dimensional vectors that we have of each product. We look at the user factor, and then just compute the dot product to calculate an affinity score. And that's quite a nice technique to basically just re-rank any sort of product listing that we can retrieve from our entire product catalog. And for any sort of product user combination, we can compute an affinity score and then just re-rank the product list based on that. There are a couple of things to think about when we want to do that. First of all, usually from any sort of full-text search engine, you get a sort of relevance score back for a specific search term. So there's a question to what extent do you want, for example, personalization to overrule this basic relevance score? Should you only look into maybe re-ranking the first 100 items or the first top items, whatever it is? But this is something that you can play around quite nicely with once you've implemented the basic functionality. In Elasticsearch, the actual implementation is done via function score query. And this is basically just a query where you can customize the relevance or control the relevance in the specific way that you want to control it. So for example, in here, we have this filter item. And this is basically just a boosting where we say if the gender of the product matches with the gender of the customer, then we, for example, apply the weight 50, and every item where this applies to would be upweighted. And then the more complex query, for example, where we could use similar items or factors, lies within a script. And that script, I think, can be in the form of various languages. And there you can quite nicely just specify exactly the rules that you want to implement. So in our case, we said we want, for example, just to upwaist anything that's based or anything that matches my top, I don't know, maybe 10 brand product type preferences. I want to calculate the affinity scores based on the user and item factors and use that as an input for the overall score. Or I want to check if the item is similar based on the sort of matrix factorization similarity concept to my last product interactions. And this then results into quite a lot of text, which looks a bit more daunting than it actually is. It basically just gets all the different elements that we retrieve from the result of our search. So every product that's delivered back from the search would have like all these different fields that we specified before. So for example, the name, the product type, or the factors. And here, for example, we just say we have all our user factors, we have all our product factors, and we just iterate through them, multiply them. So basically just building the dot product. And then that becomes a part of our overall score. And we can quite nicely re-rank the product catalog based on that. And that's basically all we need for computing or for re-ranking our search products. So this was, for example, the default search on the left-hand side, where we had a mixed search result. So we always have some male items, some female items, any sort of different styles depending on how the site is designed. And we quite simply used Elasticsearch to re-rank the items. So in this case, for example, we would have the taste vectors considered, I think, in the case where these sort of Keds shoes and Nike shoes were pushed up quite nicely. So the user was more into kind of casual shoes. Similar items have been considered. So I think Keds was in the similar items, or the customer. I think in this case it was actually myself. I used myself, I think, as the main customer, which is always kind of a nice way to trial things. And I think I bought similar shoes before. So then the algorithm would just pull up similar items to what I've interacted with before. And we could also just use simple things like the gender. So in this case, we wouldn't have any sort of male results, but just female results, and would hopefully be able to generate more relevant results for the user. And I think we're quite good in time, so I think I can just show a simple demo based on that. So this was just, okay, I have to enter my details again. Nope, okay. See if I remembered it correctly. Nope. 1 second. I think I just quickly have to. Check if this doesn't work, then maybe yes, yes, would be helpful. Thank you. Somehow I always get logged out again. Okay, great. Cool. So yeah, so basically we just came up with a very simple front end that allowed us to take this to different people around the business and just show them what would be the impact of personalization. In this case, I think if we just look for one of the brands, on the left-hand side we just interacted with the standard search API, where we just get back some results. On the right-hand side, this would be personalized based on factors. So these would be the item and user factors, item similarity, so surfacing similar items based on the last product interactions, and simple things like gender, brand, or product type. And we had some simple sliders here where we could just experiment with different weightings around it and just observe what happened when we don't have any personalization, which should hopefully, yes, just retrieve the same results. And then looking into whether we have some maybe similar items that we can retrieve, and we see, I think in this case, this would have been an item that was similar to the last purchase, just kind of pulling this up, using more information about the user to actually just re-rank the results a bit more. So I think in this case, I think one of the preferences was just dresses for this brand. So we just surfaced this up. I think these two items were driven mostly by the product factors. So just the factors that we computed based on matrix factorization. Yes, exactly. So they would then just be pulled up to the top of the search results, and that allowed us to just discuss this with different people in the business, think about it ourselves, just kind of what is the effect, how does it work, and just work on it from there on. In terms of next steps and open questions, so obviously implementing the personalization is just one part of the equation. There's a lot of other things to think about. On the one hand, like how do you balance personalization with other things like, for example, just showcasing items, showcasing new items, also just kind of the manual creation of making the site looking more visually appealing. Then how or where do we want to use personalization actually in the browsing funnel? How can this integrate into the overall architecture? So our implementation was just a simple standalone POC, and Elasticsearch worked very well for that. But then the more complex the query is, so the more complex the sort of function score part is, the slower the query becomes, and that's something that you see quite a bit when you just kind of experiment with different personalization levers. So there's so we're kind of thinking at the moment kind of how can we make this more scalable, how can we make it faster, but that's then the next step. And then also obviously kind of the whole filter bubble problem. To what extent would you want to re-weight things? Is it a solution that we, for example, just re-weight the top items, or should we re-weight everything? So this is basically just a lot of still open questions and things that we want to look into. But having the POC really helped us just to kind of get discussions started and just being able to talking about the opportunities and the risks. Cool. And that's about it. Yeah, we're also recruiting. So if you have any more questions around ASOS and what we do in data science, feel free just to kind of talk to me afterwards as well. Cool. And I think we have some time for questions right now. Yep.
Are you testing your models in some way? Like, feedback from the customer to see what they actually click on, or?
Yes, so this model is not in production yet. So this was just basically a POC for our purposes that we might look into testing internally. But yes, definitely that would be the idea, to actually understand what is the benefit of having any sort of personalization. I think you could look into maybe doing some offline testing around that. So looking into what are the things that people searched for and then ultimately went on to view, went on to buy, and use that as an offline testing. But the more robust results you usually get then from online testing. So actually maybe implementing that to some of the customers and seeing how they interact with it, whether it's more useful or not. Yeah.
Potentially you can use the historical data to evaluate some of these.
So that's what I meant with kind of offline testing, just looking into how would it have performed if we would have used it in the past. But we've seen that with offline testing, it is quite a limited way, or it has a lot of limitations in testing. So the results might not necessarily kind of completely translate into the same results in online testing. Yeah.
Your customer preference vector, do you find that you had households with multiple individuals sharing an account and that confused things? And did you observe any seasonal effects in that preference vector changing throughout the year?
So to the first question, yes, we definitely have people sharing accounts or people buying gifts for their friends or whatever. And this obviously is quite a challenge for us within recommendations in general. So we're looking into ways of kind of how can we maybe identify what was for you, what was for someone else. But especially for account sharing, it becomes a bit difficult because you don't know which user is currently online or which user you're sharing with. So I think for this, you could look into balancing more the long-term versus the short-term signals. So one approach could be that we have the long-term information about your preferences maybe over the last year, and then we see you doing something specific within this session, and just maybe rely more on that, what you're kind of currently doing. So this could maybe counterbalance if you're now looking for something else or if someone else is using your account. And in terms of the seasonal trends, yes, it's definitely something that we see. So obviously now everything is kind of more shifting towards summer wear, so beach wear. In the winter, obviously around Christmas, we also have a lot of Christmas products. They would come up more. And this is also kind of something that we think of when we think of international models. So how would it, for example, work for UK versus, I don't know, Australia, something like that. Cool. Yes?
So on the technology stack, you mentioned that you use Jenkins and Java for the import to Elasticsearch, right? So the question is, like, is there any reason why you didn't use the Elasticsearch module in Python to do the import into Elasticsearch?
Yeah, you could do that as well. We found, I think, just the implementation for us was that we use something on Microsoft Azure that's called Azure Data Factory, which is just a tool to automate data pipelines. And we already had a script from a previous trial that used Java to connect with Elasticsearch, and it was very easy to just kind of customize that. But yeah, in general, there's like a lot of different clients that Elasticsearch works with. So you could use Python, JavaScript, I think, Java, C, so whatever works best. It was just a bit of, for us, it was just a case of reusing something that was already there, and just customizing it a bit.
And just sorry, another question.
Yeah.
Do you have any challenges when using Elasticsearch? I mean, you said that you had a good experience, but there's also...
Yes, no, definitely. I think every tool comes with its own challenges. So on the one hand, it takes some time to kind of get familiar with it. So there is quite some documentation around it, but there's a lot of trial and error that went into kind of making things work. There's definitely kind of the sort of scalability concern. So especially if you have more complex queries, it might get very slow. And then, I think just the question around maintaining it. So we're running that on a VM, on a virtual machine in Azure, and we've been seeing issues with the clusters being down, and then you just kind of have to manually kind of re-invoke them. So for us, it's not a main concern because it was more kind of just a POC, but once we kind of want to take that further into production, this is definitely something that we have to look into. Cool. Yeah.
Thanks for your talk. I was just wondering, how important is real-time processing for you guys? You might have kind of mentioned it, but is it, and also in connection with maybe future work where you make a feedback loop, for example?
Definitely very important, because I think where we want to get to ultimately is being able to infer during the session actually what you want to do and kind of fine-tune our models based on what you're doing already within the session. So this will become quite important, but I think also there, like the matrix factors that we get out of the matrix factorization are quite useful because you could change them or can think into kind of how could you amend them based on the products that you have looked into during your current search, or maybe use the products that you just interacted with as the sort of basis for the similar items to retrieve things from search. But there it becomes then probably a bit more complicated in terms of how do you push this kind of sort of real-time signals back into Elasticsearch, kind of what is this sort of loop into maintaining the signals in there, or whether you have to look into kind of a different stack to manage the signals in real time and then feed that back into the search.
But so far you haven't used Spark Streaming, right?
That's something that we're experimenting with right now to see how we can work with it. Yeah. Yeah.
Python package called LightFM.
Uh,
It's a paper that lets you, it's like enriched matrix factorization to take item features as a kind of unified model. It seems like it would work.
Yes, so this is also something that I'm testing right now, and we've seen that it's working very well. So because, as you said, you can, in addition to actually the product item interaction, you can consider features for the items, for example, or features for the customer. And we've seen that the relevance improves when we're using it. So we might just think about, calculating the factors with LightFM instead and just using that as a main signal.
How do you measure the success of this recommendation system?
Well, the recommendation system in general, or the search, I think it depends a bit on whatever KPIs we're looking into. So usually, if we're looking into offline testing, we're looking at the typical KPIs like recall, position, and so on. For any sort of online proposition, we would look into things like like CTR, like click-through rates or conversion rates. Ultimately, the aim is to enable the user to find things faster or find things quicker. So then, hopefully, we would see increased conversions, more things that the user finds useful and therefore interacts with them or maybe puts into the basket, things like that.
Okay, let's thank you again for this very
Thank you.
interesting talk.